Welcome to this video on stem and leaf plots, dot plots, and histograms. By the end of this video, you should be able to use multiple representations to represent data, and you can use those multiple representations to answer questions about the data. Alright, so the first representation that we are going to talk about is a stem and leaf plot. So a stem and leaf plot is a way of organizing data and displaying data using the digits of the data values to see how they are distributed. The last digit of the data is called the leaf. The remaining digit or digits, if it's more than a two-digit number, are the stem. You should always include a key to explain what the stem and leaves represent. So when we're looking over here, our key says 2/1 means 21 minutes. So 0/9, that's 9 minutes. 1/0 is 10 minutes. Then we have 13 minutes. Then we have 16 minutes, 16 minutes, 18 minutes. Okay, so it's a way we can kind of break down the data, and we can also see the shape of the data. If we turn it sideways like this and threw a blanket over it, you can kind of see that as a skewed right distribution. It's unimodal, skewed right. Okay, so I'm not going to have us draw any. We're going to focus more on interpreting them. So we're going to use this stem and leaf plot to answer these questions. The stem and leaf plot above shows the length of a set of customer service calls. Use the data to answer the following question. So what is the mean time? Alright, so you're going to find this the way you would find the mean regularly. You're going to add up all the values and divide by the total number of numbers. So remember, the first number is 9 plus 10 plus 13 plus 16 plus 16 plus 18 plus 21 plus 24 plus 32 plus 41 plus 47 plus 53. And that's all going to be divided by, there are 12 total numbers. When I add that all up, I got 300 divided by 12 would give me a mean of 25. Okay, so we have the average number. What is the median call? So the median call will be the number right in the middle. So there's a couple ways we can do this. We can look at our list here, and I know I have 12 numbers, so it's going to be between two numbers because it is an even. So 1, 2, 3, 4, 5, 6. So my median is going to end up being right there, because then I'll have 6 numbers to the left and 6 numbers to the right. Halfway between 18 and 21 is 19.5. So this is a little bit harder because it's an in-between number. We could have taken our distribution here and counted in like you've done before and keep counting. And so between 18 and 21 was our number. So it's a little bit harder to do it that way, but you have all of your distribution, you have all of your numbers right there. So you can find the middle that way. Alright, how many calls were more than 10 minutes? So more than means greater than. It does not mean equal to. So I need to find more than 10. I can't include 10 because 10 doesn't include, more than doesn't include. So we're looking at 13, 16, 16, 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 calls were more than 10 minutes. All right, how many calls were at most 30 minutes? At most means less than or equal to. So 30 minutes or less is what we're asking. So I'm going to go to 30 minutes. We don't actually have a 30 minute, but I want to go less than that. So I've got 1, 2, 3, 4, 5, 6, 7, 8 calls that are 30 minutes or less. All right, so when we're done with this video, this practice problem is on Canvas for you to answer. So you'll put your answers in Canvas for this. Let's flip and go to the next page. So the next thing we're going to talk about is a dot plot. A dot plot is a single response to show each data value count. They are most effective for small size data sets where there aren't too many values to display. They're particularly effective at showing how one group of value compares to another. So really what you're going to do is above each one of these numbers, when you encounter a number, put a dot above the number. It's a way of tallying the data to display it, so you can end up seeing the shape of the distribution and everything. One thing I want to caution you about is to make sure all your dots are the same size. Because if you're making dots, so if you have a dot plot and you make one dot really, really big and then the next one small, and then beside it you put some more dots, they're not representing equal areas. So you want to make your dots all the same, so when you look at it you can see clearly what's going on and how they relate to each other. Okay, so when I did this one, I just went through and I said 58, put a dot above 58. 61, put a dot above 61. So pause the video, take a moment, put all your dots onto this dot plot. Alright, so here's my dot plot. So now I could answer some questions about it. You know, I can see the tally marks, how many people were 69 inches tall, and I can go to 69 inches tall and go 1, 2, 3, 4 people. So it's just a quick way to see the data. So we have two questions to answer about this. Are there any outliers? So for outliers, we're going to need the quartiles and the IQR. So we're going to get those in just a second. This one we can answer already. What is the mode? So here's the other reason. When you look and all of the dots are drawn so they're kind of equal to each other, I can see this is the tallest one, and in fact it has the most. And that's 4. So 69 inches is the mode. Alright, so let's take a look. What you'll need to do is put your data into order, and it is already in order for you, so you can make the list. You've got 58, 61, and then you have 2 62s. So finish the rest of this, find your median, your quartiles, and your IQR, and then restart the video. Alright, so I listed out all of my numbers, and I ended up with a median of 69, a Q1 of 65, and a Q3 of 72. That's going to give me an IQR is going to be 72 minus 65, which is 7. Okay, so remember our outlier rule. It's going to be whatever Q1 is, so 65 minus 1.5 times the IQR. When I put that into my calculator, I get 54.5. There are no numbers less than 54.5, so there's no outliers on the lower side. And on the other side, we're going to take Q3, which is 72, and add to it, because we're trying to find the highest number allowable, 1.5 times the IQR. And when I got that, 82.5. There are no numbers greater than 82.5, so this distribution has no outliers. Okay, so this second question, that's on Canvas for you to try on your own. Let's move on to the next one. Alright, so our final topic for today is histograms. So a histogram will tell you the number of values in the frequency of a number of values, okay? So the number of values in a particular interval. So the interval, the frequency, well, we're going to make frequency table, and that breaks a set of data values into intervals that we call bins. Like a trash bin, you put the numbers in there. It's like a place to hold them. Okay? And it shows the count for each interval. Intervals in the frequency table do not overlap, they do not have any gaps, and they are of equal size. The range of values must be the same. So what that's saying is, like when you make your number line and you go 10 to 20 and then 20 to 30, you want to have the same interval between your numbers. You wouldn't go 10 to 15 and then 15 to 30 because that's not the same interval. That's what we're saying about our bin size. When we go to draw them in, they need to be the same width. So a histogram is a graph that can display from the frequency table Okay, so you're going to take a frequency table where you're tallying the marks up and you're going to put them in this display, and it's going to show the height of the frequency that will show the number of data values in each one. So the problem here is, so a histogram in general, I'll just give you an idea. So a bin is the bar that comes up. All of these bars should be the same width. So you don't want one big, really big fat bar. That's not what we want. Them all to be about the same width. Okay. And the height of the bar tells you how many data values are in each bar. So I know this height has 2 data values. I know this height has 3 data values. This height has 2. This height has 2. The issue here is I don't know what the numbers are. I just know that there's 2 of them in here. And so if this was 10, 20, 30, 40, 50, I know there's 2 numbers somewhere between 40 and 50. From 30 to 40, there's 2 numbers. I don't know what they are. I just know that they're between 30 and 40. I know between 20 and 30, there are 3 numbers. Okay, so that's what our histogram does. So here is a set of data. And this is called a frequency table. So this is just like a tool to help you get ready to draw your histogram. So looking for numbers for 60 to 69, I kind of grouped these, but I didn't put them in order for you. So what I usually do is I look and I go 60, that's in this group. I'm going to put a tick mark. 62, that's also in this group. 65, 69, and when I get to 5, I go, so there's 5 numbers in that group. So when I go back to count it, I can go, there's 5 of them, then I can keep counting on. 64, 63, 63, and then now I'm in the next group, which is 70 to 79. So I've got 70, 70, 71, 74, 78, 79, 77, 75, 76. So what I want you to do is try to fill out the next 2 columns on your frequency table and come back and see how you did. All right, let's see how you did. This is what mine ended up looking like. So here's why when you do the crosshatch, that's 5 plus 3. So I know there's 8 in this, 5 and 4. There's 9 in this group, 5, 5 and 1. So there's 11. And there's 3 in this group. When I added them up, I got 31 total values, and I double checked and I counted all those, and there are 31 total values. So now what we're going to do is we have our scale on our graph here, and we have our heights. So the first bin, we're going to throw 8 numbers into it. So it needs to be 8 tall. So from 60 to 70 is going to be 8 tall, and I'm just going to draw 8 above there. Okay. The next group is 9 tall, so it's going to be a little bit taller. Okay. The next is going to be 11 tall. And then the last one is only 3 tall. Okay. So that's how we draw a histogram. You count the number of numbers in each interval or bin, and you throw the numbers in. So if I didn't have these numbers, all I could tell you is there are 8 numbers that are between 60 and 69 in this bin. I wouldn't know what they are. But what I want you to do is take a second, and I want you to put the numbers in order. And I want you to find the median, the actual median, and then tell me which bin it's in, and then come back to me. Okay, so when I put them all out, I used a separate sheet of paper because it was getting there wasn't quite enough room here for me. I listed everybody out. I got a median of 78, and 78 occurs in this bin from 70 to 80. I got a lower quartile of 69, which is in this first bin from 60 to 69. And I got an upper quartile of 83, which is in this third bin from 80 to 90. Now, usually you don't have the data when you're looking at a histogram. All you see is this. You can still get an idea of where the quartiles are by counting the numbers. And so let me show you what I'm going to make. I'm going to make a blank distribution of 31 because I know there's 31 total. So give me 1 second, I'll be right back. Alright, so what I'm showing you here is 31 numbers that I don't know what they are. Just going to call them X. So if I have 31 numbers, I know there's an exact middle number. So I'm going to end up with 15 numbers on either side of it with the 1 in the middle. So I'm going to count into the 15th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The next one is going to be my median. I'm going to just double check. So I counted 15 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 on that side. I know I'm exactly in the middle. That's my median. It is the 15th number. Okay, so I'm just going to write down, or actually it's the 16th number. 16th number. Okay. So to find my Q1, I've got 15 numbers here. That means they're an exact middle. 1, 2, 3, 4, 5, 6, 7, and then the very next one. The 8th number should be Q1. And we can double check that. There's 7, and then there's 1, 2, 3, 4, 5, 6, 7. So I know I've got equal breakings here. So let's do the same thing on the upper side. 1, 2, 3, 4, 5, 6, 7. So Q3 is, this is the 8th number, this is the 16th, 17, 18, 19, 20, 21, 22, 23, 24th number. Because we don't know what they are, we can't say what number it is, we just know its position. And when I count, I've got 7 X's in each of the sections between the boxes that I put on for my quartiles. Now, if you didn't have the numbers like we did here to get this, you can still tell me this information out here. And so I could say, where is the median? And if you just, you know how many data values are, so make a bunch of X's for that many data values, find the very middle. It's the 16th number. Which bin has the 16th number? So this has 8 numbers. If I add 9 to 8, I get 17. Well, that means the 16th number is in here. So my median, oops, I moved over one, I apologize. My 16th number is somewhere in this bin. I don't know what it is. That's the problem with the histogram. You don't know the exact numbers, but I know my median is in there between 70 and 79. And that's exactly what we wrote here. We used these values here in making those bins. Okay, so we know that's where the median is. We might not know this piece of information, but we can tell us where the median is. Now, we think maybe the Q1 is here, but you should always be careful and make sure you count. So when I counted, it's the 8th number. Well, there are 8 numbers in this bin, so it's the very last number in this bin is the Q1. So that was really close. It was almost in the same bin as the median. So just always make sure you count. So that's where our Q1 is located, somewhere in there, in that bin. And then our Q3, when we counted it out, was the 24th number. So we're just going to add these until we get to where the 24th number would be. This is 8 plus 9 is 17. 17 plus 11 is 28. That means the 24th number is in this one. So I don't know what the number is, but I can tell you it's somewhere between 80 and 89. It's in this bin right here. So you have to break down the numbers to figure out their position and where the position falls within these histogram bins when you can't see the actual data values. I would put a star on this because I can pretty much guarantee you there's going to be a test question about that. So what I want you to do, I gave you a shorter list to work on your own. Make your frequency table, make your histogram, answer these questions for real using the data, and then try it again using this method with the X's. This is on Canvas also. That's part of that same quiz where I want you to put your answers. Let me know if you have any questions, and I hope to see you in class soon.